Hey everyone, in the last video we talked about the blood supply to the brain that every medical student should know. Today we're going to be applying that knowledge to one of the most high stakes and high yield conditions in medicine, which is stroke. A stroke is when brain tissue is damaged because blood flow either suddenly stopped and that leads to a lack of oxygen, or a blood vessel bursts. So two main reasons for the stroke, okay? So one, the blood flow stops. So blood flow stops, and that leads to lack of oxygen. And this leads to something called an ischemic stroke, okay? Ischemic stroke, okay? And ischemia essentially just means, lack of oxygen. There's poor oxygen, okay? And an example of an ischemic stroke would be a clot from the carotid artery or the heart. So if there's a clot in the blood vessel, it's going to occlude the blood vessel, and that's eventually going to lead to ischemia of the region that it's supplying downstream, okay? So just imagine here, there's a little clot here, okay? And there's a bunch of blood flowing in here in this blood vessel, okay? And it can't pass this clot that's right here, okay? It can't pass this clot, okay? And because of that, since our blood carries oxygen and nutrients, all the tissues downstream from here, all these tissues downstream from here that are past this clot, they're not getting that much blood supply, okay? And because of the reduced blood supply, it causes less oxygen to be in those tissues, and that leads to a variety of symptoms depending on what blood vessel is affected, okay? Now, an example of a hemorrhagic stroke, on the other hand, a hemorrhagic stroke would be when a blood vessel ruptures, okay? And this is a bit more self-explanatory. So if we have a blood vessel like this, we can have a little aneurysm, for example. Let's say there's like a weakening in the blood vessel wall, okay, which leads to this aneurysm. And this aneurysm is essentially just an outpouching of the blood vessel wall. And blood can actually flow into this blood vessel wall, into this aneurysm. And if a lot of blood flows here, the aneurysm can eventually rupture, and that can lead to blood in the brain parenchyma, and that can also lead to a variety of symptoms, most commonly headache. Okay, so these are two very important mechanisms of a stroke. Okay, these are like two things that you absolutely need to know, and everything is going to make sense if you understand these two concepts. Okay, so these are the two underlying concepts that you need to know. I'm emphasizing this heavily because it's very, very important. Otherwise, nothing is going to make sense to you, okay? So if you need to pause the video, go ahead now and pause it, and take some time to understand these two concepts, okay? All right, now we're going to go ahead and get into the most common types of strokes that are present, and this is also very high yield for exams. So we're going to go ahead and come down here, and we're going to start off with strokes of the anterior cerebral artery, or ACA, and the middle cerebral artery, or MCA. And to truly understand strokes of the anterior cerebral artery and middle cerebral artery, we need to look at this thing called the homunculus. So I know you might be saying, Masterful Medicine, what the hell am I looking at? So this right here, this whole thing that you're seeing right here, this is the homunculus, okay? It's something called the homunculus, or homunculus, however you say that. What this is that it's essentially a visual representation of the human body mapped onto the brain's motor and somatosensory cortex, okay? Now, the anterior cerebral artery on the homunculus, so if we take a look here, okay? So this is the brain right here. This is the brain right here. I just outlined it for you. Now, if we go to the anterior cerebral artery over here, so we see how the anterior cerebral artery is over here. It's on the anterior portion of the brain, okay? So now when we come down here, the anterior cerebral artery would be coursing this whole area, okay? It would basically essentially be coursing that whole area, okay? So if we take a look at this homunculus, it has it kind of mapped out for us. We can see that the legs are over here in the middle, and we also have the genitalia here, right here. And let's say we got an ischemic stroke of the anterior cerebral artery, okay? So that would essentially mean that we would get contralateral leg weakness, leg sensory loss, and urinary incontinence, okay? So let me explain this. So we see that the legs are here and the anterior cerebral artery runs in this course, okay? This course that I just drew out here. So it courses that way. And as you can see in the homunculus, in this area, we see the legs here and the genitalia here, okay? So since this on the right, this is the motor cortex, this is all the motor symptoms that you're gonna get, and then this is the somatosensory cortex, so all the sensory symptoms and all the proprioception stuff like that you're gonna get, okay? And on both of the homunculi, I suppose, they're kind of similar. Like you see outside here on the lateral portion of the brain, you see the face, the tongue. You see over here also on the somatosensory portion, the face, the tongue, and then we see the hand, and then we see the legs and arms come over here, okay? So after taking a look at that, as you could imagine, if we have some type of stroke, either hemorrhagic or ischemic stroke of the anterior cerebral artery, the anterior cerebral artery is running in this distribution right here. If it's running in this distribution, that means this area is the area that's being affected. So we see the legs being affected here and the genitalia being affected here too. So that's why it leads to contralateral leg weakness, which means leg weakness on the opposite side. So let's say you have an ischemic infarct of the right anterior cerebral artery right there, okay? If you have an ischemic infarct of the right anterior cerebral artery, you're gonna get left-sided, left leg weakness, okay? Left leg sensory loss, and you're also gonna have urinary incontinence because as I mentioned earlier, this is the somatosensory portion and the genitalia are here. So you're going to have some urinary incontinence on that as well. But that's a little less important to know. The main thing to know for anterior cerebral artery strokes is the contralateral leg weakness, okay? And you might be wondering, why is it happening on the other side of the body? So that relates to the brain's neuronal tracts. And I'm not going to get into the details of that right now because I don't want to make you guys any more confused. And I'll be covering that in a future video, okay? So the main things to know, just to recap, for ACA stroke, you can have contralateral leg weakness, you're also going to have leg sensory loss, and you're going to have urinary incontinence, okay? And the main thing is the contralateral leg weakness and the leg sensory loss, okay? And now let's move on to the MCA, or the middle cerebral artery. The middle cerebral artery covers this whole area that I've outlined over here, okay? This whole area that I've outlined over here, that's basically the whole entire middle cerebral artery distribution, okay? So as you can see, let me get rid of this right here. So the middle cerebral artery would essentially cover all this, pretty much, for the most part. Like, this is a very rough estimate, right? Okay, so as you can see here, the middle cerebral artery, let's say we have a stroke in the middle cerebral artery in that distribution. So what would it affect? Well, if you're looking at the homunculus here, we can see that it would affect all of this. So it would affect our face, our hands, our arms, and then over here, it's the same thing, our face, our hands, our arms. So the way I like to think about it, as you go from lateral to medial of the brain, like the most medial part of the brain covers like the legs, okay? And the most lateral part of the brain covers like the face and the arms and the hands, okay? So in a middle cerebral artery stroke, you're gonna get contralateral face weakness, arm weakness, and sensory loss in the face or arm, okay? And this is also very important to know. So I'm going to go ahead and write that down. So an MCA stroke, contralateral face weakness, arm weakness, and the arm weakness is also contralateral here, which just means the opposite side. And you're going to also have sensory loss in the face and the arm. Okay. Now, one other thing that's really important here is that if the MCA stroke is on the left side of the brain, you can get aphasia, okay? And what aphasia is that it just means you have trouble either speaking or understanding language, okay? And the reason that this can happen is because the left hemisphere of the brain is the dominant language center for almost everyone. And it has these areas called Broca's area, which is used for formulating speech. And it also has Wernicke's area, which is an area in the brain for language comprehension. And those are both on the left side of the brain, roughly in this area, okay? So because of that, because both language regions are on the left side of the brain, if you block the left MCA, if you block the left middle cerebral artery, blood flow to the dominant language centers are going to be cut off, okay? And that's why you get aphasia, okay? So the patient can have like trouble speaking, understanding language, or both. It really just depends like on which part is affected and to what extent Broca's or Wernicke's areas are affected, okay? So that's another very important thing for the MCA stroke, okay? So you can also have aphasia. And then why? Because of Broca's and Wernicke's area on the left side. Okay, and it's important to specify aphasia only with the left-sided MCA stroke. Like most commonly with left-sided MCA stroke, if the person's dominant language center is on the left side of their brain. So that's going to be the case for like almost all people, but there's always that unique case. So you can't always be definitive. But anyways, so that's if you have the MCA stroke on the left side of your brain, or sorry, on the left MCA, you can have the aphasia, okay? So if the MCA stroke is on the right side of the brain, or the right MCA, you don't get aphasia. Instead, you get something called neglect, okay? And neglect is essentially when the patient ignores like half of their world, and it's usually the left side, okay? So let's say you have a stroke on the right middle cerebral artery, it's usually going to be the left side of the person's whole entire world that's affected. So the patient won't even look to the left, they won't eat food on the left side of their plate, and they won't even realize that their left arm like belongs to them. And this is actually like something I found really interesting when I was first learning about this, because I didn't even think it was real personally, but there's actually a famous case in which Oliver Sacks wrote in his book, The Man Who Mistook His Wife for a Hat. There's a famous patient he saw who had a right-sided stroke, and that patient developed severe left-sided neglect, and he would only shave the right half of his face and only eat food from the right side of his plate. And it wasn't because he was blind, it's because his brain simply like stopped acknowledging that the left side of his world even existed. So this is kind of interesting because his therapist like put him in a spinning chair one day, and as the patient rotated in the spinning chair, different parts of his visual field moved into his right side of his awareness for like a moment, and he'd see all the objects that he'd been ignoring the whole time. But as soon as he stopped spinning in the chair, all of a sudden he would ignore, like it's like everything in his left side of his visual field seemingly like disappeared from his attention again. So that was just a case that I found very interesting, and I just wanted to share with you all because it's a pretty good example of the right-sided middle cerebral artery stroke in reality. So let me just write that down. So right-sided MCA stroke, it can lead to neglect or ignoring half the world. Okay, now we're gonna move on to strokes of the lenticulostriae arteries, okay? So what are those arteries? So recall in the last video, I talked about these lenticulostriae arteries right here, okay? These lenticulostriae arteries. Those are essentially small branches coming off the middle cerebral artery, okay? And recall in the last video how I said these arteries are prone to narrowing or rupture in patients with uncontrolled chronic hypertension. And the reason for that is because uncontrolled chronic hypertension can lead to hyaline arteriosclerosis, which is essentially just thickening of the blood vessel wall. And the hyaline arteriosclerosis can eventually lead to narrowing and ultimately occlusion, okay? And once you occlude the blood vessel, remember what I talked about earlier here, it can lead to an infarction, okay? Right here, it can lead to an infarction in the downstream area, okay? And the lenticulostriae arteries supply the deep parts of the brain like the basal ganglia and internal capsule, and usually a stroke of them commonly leads to pure motor symptoms, and it's usually contralateral paralysis, okay? So I think the main thing that you need to know for lenticulostriae arteries are that you can get the uncontrolled chronic hypertension, which leads to hyaline arteriosclerosis, which leads to narrowing and occlusion. And this eventually leads to something called a lacunar infarct. And a lacunar infarct it's basically just a stroke caused by a blockage of a small blood vessel, okay? And these blood vessels over here, these are the lenticulostriae arteries, and they're very small, okay? So yeah, that's basically the mechanism of how that happens, and that's very important to know. And once again, a stroke of this, it's basically pure motor symptoms, okay? Pure motor symptoms, and it's usually contralateral paralysis, okay? Okay, so the lenticulostriae arteries can also get something called Charcot-Bouchard microaneurysms, and that's different than a lacunar infarct. Charcot-Bouchard microaneurysm is essentially when there's a small microaneurysm in these arteries. So let's just say, this is a blood vessel. Let's just say this is one of the lenticulostriae arteries, okay? And let's say there's a small microaneurysm like that, okay? That's essentially what a Charcot-Bouchard microaneurysm is. And when these can also rupture because of chronic hypertension. And the reason for this is because chronic hypertension leads to weakening of the blood vessel wall in this case. And that can lead to this aneurysm, okay? And like I mentioned earlier, blood can flow into this aneurysm and then eventually cause it to rupture, okay? And once it ruptures, there's going to be intraparenchymal hemorrhage in the brain, and that's a type of hemorrhagic stroke, okay? And something also to note is that Charcot-Bouchard microaneurysms, they're not visible on angiography, okay? So in this video, we covered only the most common strokes, of the anterior circulation of the brain, and in future videos I'm going to cover strokes of the posterior circulation of the brain. So let me know if you guys have any questions, and don't forget to like, comment, and subscribe, and I'll see you guys in the next one.